Problem 3. Consider the equation z minus 1 cubed equals I. Z is a complex numbers. The roots of this equation are omega 1, omega 2, and omega 3, where imaginary part of omega 2 greater than 0 and imaginary of omega 3 less than 0. Verify that omega 1 equals 1 plus e to the power of I pi over 6 is a root of this equation. Verify it's a root. You just need to do the substitution. Since 1 plus e to the power of I pi over 6 minus 1 to the third power equals e to the power of I pi over 6 to the third power equals power of a power, do the multiplication, e to the power of pi over 2i. Go to this Argand diagram. Here it's e to the power of pi over 2i. So equals I. So omega 1 equals 1 plus e to the power of I pi over 6 is a root of this equation. A2, find omega 2 and omega 3, expressing these in the form a plus e to the power of I theta, where a is all real numbers and theta greater than 0. This is an argument. First step, we need to change I into Euler form, e to the power of pi over 2i. So we get z plus 1 to the third power equals e to the power of pi over 2. Change this into general form. Then both sides take 1/3 power. We got z minus 1 equals pi over 2 plus 2k pi equals, get same denominator, pi plus 4k pi. Then times 1 over 3, we got e to the power of 6 pi plus 4k pi I. Then z equals e to the power of pi plus 4k pi over 6i plus 1. Since this n equals 3, we will get k equals 0, k equals 1, and k equals 2. So we get omega 1 equals e to the power of pi over 6i plus 1. When k equals 1, omega 2 equals e to the power of 5 pi over 6i plus 1. For k equals 2, omega 3 equals e to the power of 9 pi over 6i plus 1, which is e to the power of 3 pi over 2i plus 1. The roots omega 1, omega 2, and omega 3 are represented by points A, B, and C, respectively. On an Argand diagram, plot the points A, B, and C on an Argand diagram. If we want to plot these points on an Argand diagram more accurately, we need to change these roots into Cartesian form. E to the power of pi over 6i. Pi over 6 is 30 degrees. So this reference angle is 30, closer to x-axis. We got square root of 3 over 2, 1 over 2. So we get omega 1 equals square root of 3 over 2 plus 1/2 I plus 1 equals 1 plus square root of 3 over 2 plus 1/2 I. For e to the power of 5 pi over 6i, go to the second quadrant. Reference angle is 30 degrees. So we get 1/2 negative square root of 3 over 2. Omega 2 equals negative square root of 3 over 2 plus 1/2 I plus 1 equals 1 minus square root of 3 over 2 plus 1/2 I. For e to the power of 3 pi over 2i, it's a negative I. So omega 3 equals negative I plus 1. Write down 1 minus I. Real part of z as the x-axis. 1 plus square root of 3 over 2. We know square root of 3 equals 1.7. So 1 plus 1.7 over 2 equals 1.85. Estimate. This is A. For omega 2, 1 minus 1.7 over 2 equals 0.15. So this is a B. For C, 1 minus I. 1 minus I is here. This is a C. Remember, when you explore the point on the Argand diagram, make sure you change it into Cartesian form. Say, find AC. In this Argand diagram, the coordinates of A is 1 plus square root of 3 over 2, 1/2. C, 1, negative 1. Therefore, for AC equals, use the distance formula. 1 plus square root of 3 over 2 minus 1 squared plus 1/2 minus negative 1 is a plus 1 squared. Work this out. 3 over 4 plus 3 over 2 squared is a 9 over 4, which is a square root of 3. Consider equation z minus 1 to the third power equals I z to the third power. Z is all complex numbers. By using De Moivre's theorem, show that alpha equals 1 over 1 minus e to the power of pi over 6i is a root. Show that it's a root. What we got to do is do the substitution. So left side equals 1 over 1 minus e to the power of pi over 6i minus 1 to the third power equals denominator 1 minus e to the power of pi over 6i. Numerator 1 minus e to the power of pi over 6i. Then to the third power equals e to the power of pi over 6i to the third power. Denominator 1 minus e to the power of pi over 6i to the third power. We can use De Moivre's theorem to work out the numerator, which is e to the power of pi over 2i. Denominator is too complicated. We leave as it is. E to the power of pi over 2i is I. So we get I over 1 minus e to the power of pi over 6i to the third power. Let's go to right side to check whether we can get the same answer. Right side equals I times 1 over 1 minus e to the power of pi over 6i to the third power equals numerator is I, denominator 1 minus e to the power of pi over 6i to the third power. Since left side equals right side, so alpha is a root of z minus 1 to the third power equals I z to the third power. Let's go to E. Determine the value of real root of alpha. We need to change this into Cartesian form. Argument is pi over 6, which is 30 degrees. So when you draw this line closer to x-axis, so that you could see longer leg is square root of 3 over 2. Shorter leg is 1/2. So we get e to the power of pi over 6i equals square root of 3 over 2 plus 1/2 I. So we get 1 over 1 minus. Don't forget use parentheses. Square root of 3 over 2 plus 1/2 I equals 1 over 1 minus square root of 3 over 2 minus 1/2 I. First step, remember, always get rid of denominator. So both sides times 2. We will get 2 over 2 minus square root of 3 minus I. We will simplify by using conjugate multiply because this I cannot be denominator. So times the conjugate of this complex number is 2 minus square root of 3 plus I. Top and bottom, we times its conjugate 2 minus square root of 3 plus I. Work this out. Numerator 4 minus 2 square root of 3 plus 2i. Denominator 2 minus square root of 3 squared plus 1 squared. Numerator 4 minus 2 square root of 3 plus 2i. Denominator 2 minus square root of 3 squared equals 4 minus 4 square root of 3 plus 3, which is 7 minus 4 square root of 3. Then plus 1 equals 8 minus 4 square root of 3. Numerator 4 minus 2 square root of 3 plus 2i. Common factor is 2. Divided by 2 for both numerator and denominator. 2 minus square root of 3 plus I. Denominator 4 minus 2 square root of 3. So we get 2 minus the square root of 3, 4 minus 2 square root of 3, plus I over 4 minus 2 square root of 3. Common factor is 2. 2 minus the square root of 3. 2 minus the square root of 3, plus I over 4 minus 2 square root of 3 equals 1/2 plus I over 4 minus 2 square root of 3. So real part of alpha equals 1/2. I also want to show you how to figure out imaginary part of alpha. How to simplify this. I over 4 minus 2 square root of 3. If you have a common factor, take out. Then times the conjugate of 2 minus the square root of 3 for numerator and denominator. 2 minus the square root of 3 times 2 plus square root of 3 equals 2 squared minus the square root of 3 squared, which is 1. So we get denominator is 2. 2 plus square root of 3i. Separate 1 plus square root of 3 over 2i. Then the imaginary part of alpha equals 1 plus square root of 3 over 2.